Next up, we're going to look at something called a unit vector, and we're also going to look at an alternate form that we can write vectors in. So first of all, let's just talk about what a unit vector is. And really all this means is we have a vector, any vector with a magnitude that equals 1. The two most common ones actually have special names. The first one looks like this, 1, 0. Notice that if you found the magnitude of this, you would actually get 1. But this is called the vector I. And instead of getting confused with other vectors and symbols and anything else, we use this sort of symbol on it like that. And this is called I hat. Historically, I don't know why they picked I, but this is called I hat. And then the other one is 0, 1, and this is J hat. Now I usually use sort of cursive to write these, but you can write them normally as well. And this is just J hat. Now, if you're kind of thinking about what these vectors really mean, they basically just stand for our coordinate system. I hat goes a distance of 1 in the x direction, and J hat goes a distance of 1 in the y direction. So really these are just vectors that define our coordinate system xy like this. And this leads us right into an alternate form to write vectors in. So we can say this is called a linear combination of I hat and J hat. And what we could do is, let's go back to a vector we've been using, 1, 3. We could rewrite this as 1 I hat, or just I hat, plus 3 J hat. And that means the exact same thing. When you get used to vectors, you'll see these and kind of understand them to mean the same thing. Or, so there's one example. Let's say I had 5, -3. This would be 5 I hat minus 3 J hat. So all this is saying is that I'm going 5 in the x direction and -3 in the y direction. Now, sometimes this is more useful, sometimes the other form is more useful. It really just kind of depends on what class you're taking and where you are in your math career or physics career, depends on what you'll want to do with this. So these are the most common forms of unit vectors that we'll be using, I and J hat. But I want to mention another use you might have for unit vectors. So the reason we use them is because they really help us define coordinate systems like this. If you had, let's say, like a ramp, and you had, this is probably a classic physics example, notice that there's a force that kind of goes this way called the normal force, and then there's also some stuff here we're thinking about our force diagram, and of course there is gravity as well. But what you might notice here is we might want our x and y axis to actually be these instead, F1 and F2. So what you might do is you might find a unit vector in the direction of F1 and another one in the direction of F2. And then that way you can rebuild your problem and kind of restructure your coordinate system so you're not using I hat and J hat anymore. And so this is a reason you might want to use unit vectors in, here's an example of a physics problem, but it's helpful sometimes to have unit vectors in the direction of your forces because that helps you define a new coordinate system. So let's talk about how we might find a unit vector. All right. So we're going to determine a unit vector in the direction of, let's go back to my first example, which was 1, 3. And the way you do this is you just take your vector v, whatever it is, and you divide it by its magnitude. And this will automatically give you a new vector, which we could just call u maybe for unit vector. And u will have a magnitude of 1 based on this construction. So the first step is going to be to find the magnitude of v. We did this already. It's going to be the square root of 10. So then we just divide v by the square root of 10, which is like multiplying by a scalar. So that means that my unit vector, which I'll call u, is just going to be 1 over the square root of 10, and then also 3 over the square root of 10. Let's go ahead and rationalize the denominator as well, just to get more practice with that. So I'm going to multiply the numerator and the denominator of each of these by the square root of 10. And so then this would be my unit vector. That's in that direction of that v vector originally. Okay, let's just do one more, and this is also just practice with our new linear combination of I hat and j hat, so a new format for writing vectors. So let's do the same thing, determine a unit vector as above, except now we're going to do v equals 5i hat minus 3j hat. Of course, if you want, you can always just convert this back into component form, but what we're going to do is figure out the magnitude of v, which we've done already in a different problem, the square root of 34. We'll divide each component by the square root of 34, so my vector is going to be 5 over root 34 I hat minus 3 over root 34 j hat. Rationalizing the denominator, I end up with this. And that's it. The rest, so going back to how we started this video, using I hats and j hats, the rest all works out the same. You add the I hat, collecting like terms, scalar multiplication all works the same. Finding the direction, angle, and magnitude work the same. So all of that is very similar to what we did in previous videos. Okay, so we essentially now have two different ways to write vectors. We have its component form. We also have the I and j hat form. Both of those rely on an xy coordinate system, and basically we're just telling you the x and the y. However, sometimes we don't really care about the x and the y components. Sometimes you'll be given a vector, so let me go ahead and write this down. Sometimes you'll be given just the magnitude and direction angle. Which is fine. That's kind of like the example I started off this whole section with. You know, the plane is going 550 miles per hour and it's bearing 45 degrees, which is northeast. So sometimes that'll be given to you. However, it makes it easier to solve problems if you're able to break it down into component form. So let's talk about what that will look like. So if you are given some magnitude, which I'm going to call r as kind of a reference to the radius on a circle. This is pretty common notation throughout a lot of different subject areas in math. Complex numbers, this comes up, and unit circle, trig stuff, this comes up. And a direction angle, which we'll call theta. Then what this means is, let's say my theta is over here, and I have some r that looks like this, and there's my vector. What this means is if I want to find out my I hat and j hat component, or my x and my y component, however you want to think about this, in order to do that, I'm going to have to use some right triangle trig to find it out. And really what we're going to do is just use sine and cosine in this case. So sine will give me the y value, cosine will give me the x value. So if we're given that, then the vector in component form is just going to be r times cosine of theta and then r times sine of theta, which is usually rewritten as just r times the vector cosine of theta, sine of theta. And what's really cool about this form is that this part here, this is actually a unit vector. And that's essentially a direction. It's telling you which angle you're going at, and then r tells you by how much. So this is kind of a nice way to write this out. When you're given a direction, angle, and a magnitude, you can rewrite it like this so you actually know, oh, this is where I'm headed, and this is how fast I'm going, or how much the force is, whatever it might be. So as an example, let's just say I wanted you to convert a vector with magnitude equaling 5 and direction angle we'll call 125 degrees. Let's convert this into component form. And most of the time you will end up with some pretty messy decimals. So let's say round to 3 decimal places. Okay, so the first step is pretty straightforward. We know that V is going to equal R times cosine, we know what R is, so I don't even need to write that. V equals 5 times cosine of 125 degrees, sine of 125 degrees. So that's good. We already have our component form mapped out. Now we just have to actually plug this into the calculator and see what we approximately get. So let's go ahead and open up a calculator. And we're going to do 5 times cosine of 125. That gives me about negative 2.868. And then 5 times sine of 125, 4.096. So that's my answer. I get negative 2.868 and 4.096. Or you could write this using I hat and j hat, and you would just say that this is negative 2.868 in the direction of I hat, which is x, plus 4.096 in the direction of j hat, which is y. You could graph this, you could do some other stuff with it, but the big takeaway here is rewriting it in this format. So we really have 3 different ways to write vectors. We've done a couple different operations on the vectors. We found unit vectors. We talked about how to add and subtract directions and all that. But we really have 3 different ways. That was the main story in this unit. The first way was component form. The second way was a linear combination of I hat and j hat. And then the third way we just talked about was kind of this magnitude direction form. It's not really the technical name for it. There isn't really a technical name for it. But just to kind of summarize things. So this was all sort of the intro to vectors, rewriting them in different ways. It was also meant to sort of build your tuition and also to connect back to what we did in trig. So hopefully you made a lot of connections here. We didn't do a whole lot of sort of heavy-duty problems. It was really just kind of talking about what a vector is and how to rewrite it in these different forms. In the next section, we'll start to look at a couple more types of problems we can solve.